Okay, so this video is going to cover the greatest common factor. This will help you with how to find it, how to use it to factor expressions, how to check your work by distributing back, and the most common mistakes with it. So the greatest common factor is the largest number or variable that divides evenly into every term of an expression. Finding it lets you factor or simplify the expression into a cleaner form. To find the GCF of a group of numbers, let's start by listing all the factors of each of these. Okay, so for 6, 9, and 12, the factors of 6 are 1, 2, 3, and 6. The factors of 9 are 1, 3, and 9. And the factors of 12 are 1, 2, 3, 4, 6, and 12. Now we need to find which factors appear in all three of these lists. 1 appears in all three, 3 appears in all three, nothing larger appears in all three. So the GCF of 6, 9, and 12 is 3. For these variables, you can look at the exponents instead of listing factors. Given x cubed, x squared, and x, the powers are 3, 2, and 1. You take the lowest, which is 1, so the GCF is x. One important rule is if a variable can only be part of the GCF if it appears in every term. If one term is a plain number with no variable, the variable does not go into the GCF. Okay, so we have a golden rule. The GCF of an expression is always the biggest shared number times the lowest power of each shared variable. For 6x cubed plus 9x squared minus 3x, numbers 6, 9, and 3 share a GCF of 3. Variables x cubed, x squared, and x have a lowest power of x. Combined GCF is 3x. So here's our first example, 3x minus 9. The two terms are 3x and minus 9. Factors of 3 are 1 and 3. Factors of 9 are 1, 3, and 9. The biggest shared factor is 3. The term minus 9 has no variable, so no variable goes in the GCF. The GCF is 3. Divide each term by 3. 3x divided by 3 equals x minus 9 divided by 3 equals minus 3. Write the GCF outside and what remains inside parentheses. So the answer will be 3 times the quantity x minus 3. So this one does look a little more complicated, but don't freak out. Stay with me, okay? So the second example is 6x cubed plus 9x squared minus 3x. Okay, so 3 terms, let's break it each into its number part and variable part. The numbers are 6, 9, and 3. The GCF of the numbers is 3. Okay, so the variables are x cubed, x squared, and x. The lowest power is x. The GCF of the variables is x. Okay, so then the combined GCF is 3x. So divide each term of, 6x cubed divided by 3x equals 2x squared. 9x squared divided by 3x equals 3x. And minus 3x divided by 3x equals minus 1. So the answer is 3x times the quantity 2x squared plus 3x minus 1. Distributing back is how you verify a factored answer. After factoring, you're going to multiply the GCF back into the parentheses. If your factoring was correct, you'll get back to the original expression. Factoring and distributing are opposites. They undo each other basically, and this is the distributive property. A, B plus C equals AB plus AC. Starting with 3x times the quantity 2x squared plus 3x minus 1. Step 1, the GCF outside is 3x. Step 2, 3x times 2x squared equals 6x cubed. Step 3, 3x times 3x equals 9x squared. Step 4, 3x times minus 1 equals minus 3x. Keep the sign. And step 5, write them together, 6x cubed plus 9x squared minus 3x. That matches the original, so the answer is correct. This is a simpler one, so it will be pretty easier to understand. So verifying 3 of x minus 3 is 3 times x is 3x, and 3 times minus 3 is minus 9, and the result would be 3x minus 9, and that is correct. This one also looks like it is probably complicated, but it's actually not. Just pay close attention to the signs when distributing back. 5x times the quantity x plus 2 gives 5x squared plus 10x. 5x times the quantity x minus 2 gives 5x squared minus 10x. Minus 3 times the quantity x plus 4 gives minus 3x minus 12. Minus 3 times the quantity x minus 4 gives minus 3x plus 12. When the GCF is negative, every sign inside the parentheses flips. So go term by term. These are the 6 common mistakes, so learn these now so you don't lose easy points on tests or general homework. This is mistake number 1. Choosing a factor that's not the greatest. So the problem that we have is 12x squared plus 8x. If you pick a GCF of 2, you get 2 times the quantity 6x squared plus 4x. That is factored, but it's not fully factored. The expression inside still shares a factor of 2x. The correct GCF is 4x. 12x squared divided by 4x equals 3x. 8x divided by 4x equals 2. So the answer would be 4x times the quantity 3x plus 2. After factoring, always check if the numbers inside the parentheses can still be factored. If they can, your original GCF was too small. Okay, this is mistake number 2. Using the wrong variable power. So the problem we have is 10x to the 4th plus 6x squared. If you accidentally try to use x to the 4th in your GCF, you end up dividing 6x squared by 2x to the 4th, which gives you 3 over x squared. That creates a fraction, which means the variable power you chose is wrong. Always use the lowest exponent. The correct GCF is 2x squared. 10x to the 4th divided by 2x squared equals 5x squared, 6x squared divided by 2x squared equals 3. So 2x squared times the quantity 5x squared plus 3 is the answer. If your division produces a fraction, it is an immediate red flag you should worry about that you possibly chose too high of a power. This is another mistake, leaving out a term inside the parentheses. So the problem we have is 6x cubed plus 9x squared minus 3x. If you write 3x times the quantity 2x squared plus 3x, you are completely skipping the third term. Distributing that back only gives you 6x cubed plus 9x squared, which leaves you missing the minus 3x. Every single term must be divided by the GCF. The number of terms inside the parentheses must always equal the number of terms you started with in the original expression. The correct answer would be 3x times the quantity 2x squared plus 3x minus 1. Mistake number 4, dropping or flipping signs. So the problem that we have is minus 4x squared plus 8x minus 12. Ignoring the negative and just using a GCF of 4 leads to the wrong signs inside the parentheses. When the leading term is negative, it is a best practice to factor out a negative GCF. So using a GCF of minus 4x squared divided by minus 4 equals x squared. And 8x divided by minus 4 equals minus 2x. And minus 12 divided by minus 4 equals 3. So the answer would be minus 4 times the quantity x squared minus 2x plus 3. Just remember your sign rules here, okay? A negative divided by a negative is a positive, and a positive divided by a negative is a negative. Mistake number 5. Writing 0 instead of 1 when the GCF equals the whole term. So the problem is 3x squared plus 3x. And dividing 3x by the GCF of 3x gives you 1, not 0. Writing 3x times the quantity x plus 0 is completely wrong. Any term divided by itself always equals 1. So the correct answer is 3x times the quantity x plus 1. This is the final mistake that I'm going to talk about. Including a variable that does not appear in every term. So the problem is 5x cubed plus 10x minus 15. The term minus 15 has no variable. Accidentally including that x in the GCF gives you minus 15 divided by 5x, which equals minus 3x over x. That creates a fraction which tells you it's incorrect. The GCF is 5 only. 5x cubed divided by 5 equals x cubed. 10x divided by 5 equals 2x. Minus 15 divided by 5 equals minus 3. And the answer is 5 times the quantity x cubed plus 2x minus 3. A variable goes in the GCF only if it is present in every single term. So, as a quick reference, the 6 mistakes that we went over are all of these. It's for number 1, let me go over it just real quick. You can skip, but so for number 1, GCF too small. Check. Can the parentheses still be factored? And number 2, the mistake is the wrong variable power. Use lowest exponent. Result must have no fractions. For number 3 mistake, missing a term. Term count inside parentheses. Original term count. Mistake number 4, sign errors. Negative GCF flips all signs. Always check each one. Mistake number 5, writing 0 instead of 1. GCF divided by itself equals 1, not 0. And mistake number 6, variable not in all terms. Variable in GCF only if it appears in every term. If you do want to put yourself to the test, I recommend doing these questions in equations and not only checking back with distributing, but also checking if your answer matches up with the one on the right. And I feel like it will be easier because you have a reference to look back at. So do each one of these, as the last one is pretty hard, but the first one, it should be easy and it'll gradually get harder. But I recommend trying these if you really want to memorize how to do these. In the summary of GCF factoring, for the first one, you find the GCF of the numbers, you list the factors, you pick the greatest shared number. The next step you do is finding the GCF of variables. Variable must be in all terms, so you pick the lowest power. And for the third step, combine. The GCF equals number times variable or variables. And step 4, divide each term. And each term divided by GCF equals what goes inside parentheses, which will be the terms. So for step 5, and write factored form, all the terms will be in the parentheses, and the GCF will be outside of the parentheses. So all the terms that you have, it goes inside the parentheses. And step 6, distribute back. You multiply GCF back through to verify your answer.